Hi dears, today we can deal with the subject repulsion between a coil carrying an AC and a neighbouring conductor. Here we have the apparatus to study this topic. Okay. Here this is the laminated soft iron core and a coil insulated wire A is wound on the soft iron core, and also the laminated soft iron core has made with an extra length which is to be used for the aluminium ring to slip over this. Okay, so this is the laminated soft iron core. A is an insulated coil which is wound on the soft iron core, and this soft iron core has an extra length to slip the aluminium ring B. And about the aluminium ring, it has a self-inductance L and a resistance R. That is, this aluminum ring is having an inductance and a resistance, that is LR. And this coil, both ends are connected to an AC EMF. Okay. Now, let M be the mutual inductance between the coil and the ring. That is, the coil is A and the ring is represented as B. So, A and B will be having a mutual inductance M. Now, if let the alternating current flowing through the coil be represented as I is equal to I0 sin omega t, and due to the mutual induction, EMF is induced in the ring, which can be written as E is equal to minus M di by dt. That is, E is equal to minus M d by dt of I0 sin omega t. As we know, I is equal to I0 sin omega t. That is, by differentiating, we get it as minus cos omega t. And also, this minus cos omega t can be substituted as sin omega t minus pi by 2. So, this will be m omega I0 into sin omega t minus pi by 2. And now we have to derive the AC current induced in the aluminium ring, which is an LR circuit. That is, I prime is equal to E by Z. As we know, in case of an LR, the impedance of that ring will be equal to root of R square plus L square omega square. And if we substitute this E here, that is, I prime is equal to M omega I0 divided by Z, that is root of R square plus L square omega square. And we know, in case of an LR circuit, the current is lagging by an angle phi with the EMF. So, we have induced here as I prime is equal to M omega I0 sin omega t minus pi by 2 minus phi. That is, phi indicates that current I prime in the LR circuit, that is LR circuit means the aluminium ring, behind the EMF by an angle phi in phase. So, we have substituted that minus phi phase change in this equation. And we know, being an LR circuit, the impedance of the aluminium ring we have derived like this, and the phase change will be equal to tan inverse L omega by R. That is, phi is equal to tan inverse L omega by R. These all we have already studied. Now, force between the coil A and the ring B is proportional to the product of currents in A and B. As we know, the current passing through A is represented as I, and I prime is the current passing through the B. So, force can be proportional to the product of I and I prime. So, the force between the coil A and B can be F is proportional to I prime. That is, we know I is equal to I0 sin omega t, and I prime is M omega I0 sin omega t minus pi by 2 minus phi divided by root of R square plus L square omega square. As we know, sin A minus B is equal to sin A cos B minus cos A sin B. So, in this term, sin omega t minus pi by 2 minus phi, we can write it as sin omega t minus pi by 2 plus phi in bracket. That is A minus B form. So, now we can expand this like this. Sin A minus B, that is sin omega t cos pi by 2 plus phi minus cos omega t sin pi by 2 plus phi. Now, by expanding that f is proportional to m omega I0 square sin square omega t cos pi by 2 plus phi minus of this term divided by root of r square plus L square omega square. In the next step, I am repeating with this first term, and the change is sin omega t cos omega t can be written as sin 2 omega t by 2. That is sin 2a is equal to 2 sin a cos a. So sin a cos a can be written as sin 2a by 2. So we are replacing here sin 2 omega t by 2. All the remaining terms are same in the previous equation. Now, when we consider the terms over a cycle, sin square omega t value will be equal to 1 by 2 and sin 2 omega t will be 0. That is, over a cycle, sin square omega t will be having the value of 1 by 2 and sin 2 omega t will be having a value of 0. When we substitute here, this term will be vanishing. So, over a cycle, if we consider the average force between A and B over a cycle, the second term will be vanishing, and the first term, the value of sin square omega t can be substituted as 1 by 2. So, by substituting the value of average value of sin square omega t and sin 2 omega t, we get the average force between A and B over a cycle as F is proportional to 1 by 2 m omega I0 square cos pi by 2 plus phi divided by root of r square plus L square omega square. In case of the ring B, we know phi is equal to tan inverse L omega by r. And this is also less than that of pi by 2. Okay. So, cos pi by 2 plus phi can be written as minus sin phi as it is less than pi by 2. Now, when we consider cos pi by 2 plus phi is equal to minus sin phi, in this equation, this will be equal to average force proportional to minus 1 by 2 m omega I0 square sin phi divided by root of r square plus L square omega square. Now, this negative sign in this force indicates that net force over a cycle corresponding to the currents in A and B will be in opposite direction, so that the magnetic field produced in the coils A and B also will be in opposite direction. So, the like poles will be produced at the end face of the coil and ring face adjacent to it. Hence, there will be a strong repulsive force produced in that. So, the force produced due to the currents from the A and B are in opposite direction indicates the negative sign, means that the current produced from here and here will be in opposite direction. Which means that the magnetic field from the coil A and the ring B also will be in opposite direction. That means the magnetic field in A in opposite direction to B represent that the like poles of the coil will be having with the adjacent ring. So, if there is the south position here, here also the adjacent side of the ring will be having the south pole. So, it will be repelled. So, a strong repulsive force is produced in between the nearby positions of the aluminium ring when we place this aluminium ring towards the soft iron core. Due to the opposite direction of the magnetic field produced in both the coil and the ring produces the like poles to the nearby sides, which produces a strong repulsive force. Due to this strong repulsive force, when the ring is placed here, the ring will be violently forced to move in the upward direction. That is, the ring will be moved or jumped in the top direction or to the height. If the ring is pushed to stay back here on the soft iron core, then a high amount of heat is produced there due to this strong repulsive force present there. And this repulsion between the coil carrying AC and the neighbouring conductor is also known as the jumping ring due to this character. So, hope you all understood the topic. Thank you.